Okay, so something that's kind of important in linear algebra is creating something called an augmented matrix, which is just a way of solving like a linear system of equations, but making it like a lot easier and a lot nicer to look at. So let's just look at an example, and then we can go from there. So I'm going to start off with a pretty basic example. This is just with two variables, but this is exactly like the only thing that nothing really changes when we go up in variables. So this is one of the two equations, and then this can just be the other one. And in this case, we're not solving it yet. That can come in another video, but we're just thinking about how to put this into an augmented matrix first off, because that's really the first step. So all we do here, I'm going to make my little matrix. So each kind of column corresponds to a different part. So the first column here is going to correspond to our x's. So we can pretty much just write a 2 and then a 3. This next column is going to correspond to the y's. So as we did earlier, we're going to write the coefficients. So 5 and then 9. And then, oops, this is a bit of a mistake. I need to make this a little bit bigger. So then this final column corresponds to our answers. So what you typically do is you just draw this little line that pretty much shows that you're separating it from the coefficients on the left. So this is exactly how the augmented matrix for this for these two equations. This 2 goes here, this 3 goes here, 5 goes here, 9 goes here, and then these answers go on the right side, okay? You only need to put the coefficients. You don't need to bother with the x and y. The x and y, I guess my interpretation is that they're kind of like implicitly over here. Okay? So that's what you do. Let's do another example. We can go into 3 variables, because that's probably what you're going to be doing in your class, not sticking just with the 2 variables. So I'll just make 3x plus 2y plus 5z equals -10. That's going to be 1. -4x plus 2y minus 3z equals 5. And I haven't actually worked these out, so I don't know if there is a solution. This is literally just how to put it in an augmented matrix. So don't come at me if there's no solution, but this is just the focus of the video is putting it into an augmented matrix. So from here, remember what we're going to do. The x can correspond to this first column. I'll put it down here. The y corresponds to this column. This new z can correspond to here. And then this final column can be like solutions. Okay? Draw a little line there. This can be 2, -4, 3. This will be 3. This will be 2. This will be 4. So just kind of going over to be thorough. These coefficients all here go right there. These coefficients go right here. These coefficients go right there. We draw this line, and our solutions go right here. Okay? And from here, you can do row reduction and things like that, but that's kind of later. The first thing you learn is probably how to put it into an augmented matrix. So I hope I helped. This isn't really too bad, and neither is row reduction, honestly. But it's just different from what we've done. So remember, you just put all the things with the same variable into a column. So like all the x's here, all the y's here, all the z's here. Your professor might try and trick you up by doing like 3y here and then plus 2x. So like moving the x and y around in these places. But you just need to remember that you can put all the x's here, all the y's here, and all the z's here. Okay? I hope I helped. Thanks for watching.